data. And because this data is coming from the outside world, we have to decode it before we print it. And then when we're all done, we break out of here and we close the socket. So literally, that is an entire web browser written in 10 lines of Python. And again, this is why everybody loves Python. So this is what this program will show if you run. The get is sent. It looks exactly like doing it by hand. You get some headers. Again, this is metadata that tells you something about the file. In this case, one of the important things is what kind of thing is coming next. There's always a blank line as a break between the headers and the actual data, the metadata and the data. And then here is the actual text of that romeo.txt file. And then it's going to run this, going to print data.decode. All this is coming from the print statement. If you were going to parse this, you have to know that you're going to read the headers up to a blank line. The blank line is your indication as a software developer that the headers have stopped and the actual text begins, and you know the syntax. This actually could be a JPEG or a PNG or some kind of image, right? And this data would here look like blah. So if you type this and you change that code to actually go retrieve a JPEG URL, gibberish will come out, okay? And so that's exactly what you will see. And so now you have built a very simple web browser. Next, I want to talk a little bit about what happens when characters transition from outside your computer, from inside the computer in strings, out across these sockets to servers and then back.
Hello everybody and welcome to some worked sample code. If you are interested in the source code, you go to materials and download this sample code.zip. I have this downloaded. It'll be in a folder called code 3 on my computer. This is where I'm at. I'm in the code 3 folder, and this has a ton of bits of code here. So if I do an ls, you'll see I got all these files here, and so we'll just leave those there. And so this is the one I want to work through right now, is this socket1.py code. And basically what we're doing here is we're simulating what is going to happen in a web browser. And the cool thing about the HTML, the HTTP protocol, is that we can do this by hand. And I'm actually going to hack this HTTP protocol. This is going to go to data.pr4e.org and retrieve a document. And so I'm going to do telnet now you can do this on a Mac and Linux, and if you put telnet on a Windows box, you can do it here, data.pr4e.org. And I want to talk to port 80, and the port 80 is a different port. It's a non-standard port, but what we're doing here is talking to the HTTP port. And so I'm going to be able to hand send commands to the web server and retrieve a document. So I'm going to cut. I've already copied this string, this get http romeo.txt. I'm copying that into my buffer because if I wait too long, this won't work. So here I go, and now I'm going to type that, and I have to hit enter twice. And that literally was the HTTP protocol. What I typed there was the HTTP protocol, and the web server responds with some metadata about the document. How much data there is, the kind of data is there. A blank line separates the header information from the body of the document. If I was to go to this in a browser, right there, you would see, and if I turned on Developer Console and I went to the network, let's make this a little bit bigger, you would see that it retrieves this file romeo.txt, and it gets back that it shows us the headers, and it shows us the response. And so this is all the same way of doing the same thing, and that is how to do the HTTP protocol. Okay? But now we're going to do this in Python, and so here's the code we're going to write. So we're going to import the socket library, and we're going to make a socket. Now this doesn't actually make a connection. Think of a socket as a file handle that doesn't have any data associated with it yet. And then what we're going to do is we're going to reach out and connect that socket to a destination across the internet with the domain name of data.pr4e.org. And the second parameter in this tuple, this is a function call with a single tuple as a parameter. And so tuple sub 0 is data.pr4e.org, and tuple sub 1 is the 80, which says I want to talk to port 80. That could fail. It will make the connection, and if the port 80 is there, away it goes. And then we're going to actually send the HTTP command. So get, this is the HTTP rules, followed by an end of line, followed by a blank line. So you saw me do this. This was what I typed here, and then I had to type a blank line. Now, if you want to go read the RFCs for how to do this, you can figure this out. So the only other thing that's kind of weird here is we have to add this dot in code. And that's because there are strings inside of Python that are in Unicode, and we have to send them out as what's called UTF-8. And in code converts from Unicode internally to UTF-8. So this command is a set of UTF-8 bytes that we're then going to send. It still has that same set of characters in it, and now we're going to send it. And that's after we've made the connection, we're going to send these two things, and then we're going to wait. And my sock is like a file handle at that point because it's been opened and we've sent data. The HTTP protocol told us what we had to send and the fact that we did have to send it. So now I have just a simple while loop, and I'm going to ask up to 512 characters and receive up to 512 characters and get that back. If I will know that this is the end of file if I got no data back. So if the length of the data, the byte array that I got back is less than 1, then I'm going to quit. Otherwise, I'm going to print the data, and I'm going to use this decode, which is kind of the opposite of this encode. What I'm getting is UTF-8 encoded data, most likely, and decode basically converts it to the internal format called Unicode that runs inside. And so this is going to run a bunch of times, pulling in the blocks, basically 512, up to 512 characters at a time, printing it out, and then when it's all said and done, we will close that connection. And so it's not too exciting. Python 3 socket 1.py, and you'll see that it's just going to, Python is now going to do what I did by hand. Now, of course, the interesting thing is these are all in strings, right? And so, this way we could write code that does stuff with this. But all we're really trying to do in this particular situation is show how you open a socket, send a command, and then retrieve the data.
Okay, so now it's time to teach you a bit of complexity about text processing. Up till now, we've kind of been ignoring the complexity of text processing. Everything that I have been doing, most of what I've been doing is in ASCII, the Latin character set, the character set that, United States, Europe, lots of Western civilizations use this character set. And if you go back to the 1950s and 1960s, we were happy to have one computer, and we didn't care what the character set was as long as what you typed on the keyboard came out on the printer. The internal representation didn't matter. And as the 70s and 80s came along, certainly 70s, we needed some interoperability, and so they standardized on a character set, but they standardized on a character set certainly in the West that did not represent anything. And so if you look at this this sheet, basically what it's telling you is for the various characters, there's some non-printing characters, white space, non-printing characters, and then here's some printing characters like the and key, the 0, and then the uppercase characters, and then the lowercase characters. And there's 128 of these possible values. And there are nothing even for Spanish or French in here. And it's also why, by the way, uppercase lower letters in Latin sort lower than lowercase letters, and we saw that in some of the string stuff. And what these do is it maps and says, okay, and a lowercase a maps to the integer number 97, which in base 16 is 61, and in octal it's 141. But in binary, it's 8-bit numbers, and so these are 8 bits, otherwise known as a byte. And they're very efficient. Like when you buy a disk drive, it's megabytes or gigabytes or whatever. That's how many of these kind of characters it can store. But unfortunately, this doesn't work for more complex characters. You can figure out these numbers inside of Python by by using the ord function. And so you say, what is the ordinal, or the numeric representation of the uppercase H, lowercase e, and new line is a character as well. And so like 10 is the ordinal position of new line. And this actually has